A proton is moving along the x-axis at the speed of 78 meters per second. It enters a magnetic field of strength 2.7 Tesla. The angle between the proton's velocity vector and the magnetic field is 38 degrees. So this is going to be the angle between the velocity vector and the magnetic field. The mass of the proton is 1.67 times 10 to the power of negative 27 kilograms. Part A, calculate the initial magnitude and the direction of the magnetic force on the proton. Part B, determine the proton's initial concentration. So in order to find out the magnetic force, F equals to B times V times Q times sine theta. F is the magnetic field in terms of Newton. B is the magnetic field strength in terms of Tesla. V is the velocity. Q is the charge of particle. And sine theta, theta is the angle between magnetic field and velocity direction. So in this case, they form 38 degrees. So theta is 38 degrees. So B is given, which is 2.7 Tesla. V is 78. And Q is proton. Proton is 1.6 times 10 to the power of negative 19. That's the charge per proton. And sine theta is going to be sine 38. So in order to calculate it, 2.7 times 78 times 1.6 times 10 to the power of negative 19 times sine 38. That is going to give me 2.075 times 10 to the power of negative 17 Newton. That's the magnetic force. We need to find out the direction. It is on the x-axis, it's moving on the x-axis. Let's say this way. Magnetic field is going to go 38. It means that the force is going to come out of the page. That's going to be the direction of the magnetic force. So it is going to be out of the page. Now in part B, it says determine the proton's initial acceleration. Initial acceleration is A from second's law of Newton. F equals to ma. A is F divided by m. F is magnetic force. There is no other force there. Divided by m. M is the mass of proton, which is 1.67 times 10 to the power of negative 27. And when you calculate it, that's going to give me 1.2 times 10 to the power of 10 meters per second square. That will be the proton's initial acceleration.